Hello everyone, welcome back to my channel Gems of Knowledge. So today I am going to deal with the SSLC midterm examination paper, that is 2025-26. Okay, and the key answers of that particular examination. We are going to deal with the physics part in today's video. Okay, so just in case if you are new to my channel, please take a moment to subscribe to my channel and click on the bell button to get the notification as soon as I post my new video. So here the first question is multiple choice question, which is of 1 marks. Okay, so the question here is the field line inside a current carrying solenoid are parallel. Okay, if the field line inside the current carrying solenoid are parallel, then the magnetic field will be dash. Okay, so if the magnetic field lines are parallel, then definitely the magnetic field lines inside the solenoid are going to be equal. Okay, next, an electric current flowing through a conductor for 2 seconds. Okay, current is flowing through a conductor for 2 seconds generates j joules of heat. Okay, so as soon as we see j joules of heat, we should remember the formula is h is equals to I square RT. Okay, and it produces j joules. Okay, j joules in 2 seconds means I square R, and this T is 2. Okay, if the current flowing through the same conductor is doubled, now if this current only, this is for the first one. Okay, now if the condition this only is doubled, okay, now doubled means 2I square. Okay, and passed for half second in the sense in place of time it will be 1 by 2. Okay, then the amount of heat generated, what is the amount of heat generated? The condition, this condition only is altered here. Okay, time is changed by 2 to half, and this I square is doubled. Okay, now what is remaining, you just can see, if you alter this, 2 ones are 2, 2 ones are 2 is cancelled. Again, what is remaining? The heat is remain the same. It will be J as it is. So the answer is J itself. Okay. Next question. Answer the following. Name the device used to vary resistance in the electric circuit. Name the device which is used to vary. Vary means change the resistance in an electric circuit. It is called as variable resistor. Variable resistance or variable resistor, the device is called as. Okay, then why does a magnetic needle pot near a bar magnet deflect? So they are asking us, magnetic needle, we are having a magnetic needle, when we bring it nearer to the bar magnet, why it is deflecting? It is just because the magnetic field inside that needle. Okay, we can write due to magnetic field in that particular needle. Okay, next, part of a diagram showing the flow of current in a circuit is given. Okay, so one diagram is given here which shows the flow of current in that particular circuit. You can see the current is flowing like this, then it is moving in this manner. Okay, from here to here and from here to here, then it moves from here and from here, then okay, this is the direction. This is I1, current 1, 2, 3, 4. This is resistance 1, 2, 3 and 4. Okay. Now the condition is if I1 is greater than I2. So I1 is greater than I2. Here more current is passed than this. Okay. And I4 is greater than I3. Here I4 is greater than I3. Okay, now I1 is greater in this part, I1 is greater, and in this part I4 is greater. Okay, it means these two are smaller. Okay, next condition, I2 is equal to 2 times I4. I2 is 2 times I4. Okay, means I4 is smaller than I2 again. Okay, because I2 is 2 times this particular currents 2 times this is. Okay, these two are greater, this is greater than this. Okay, then the resistance of which resistor is more, they are asking. So just see, as they have already told us the condition, I1 is greater and I4 is greater. Okay, I1 is greater than I2. Okay, this is greater, it means this is having less resistance. Okay, they are asking us which resistance is more. If the current passing is more, then the resistor is having less resistance. Okay, so I1, see, I1 is greater than I2, means it is having more resistance than I2. Now what is I2? I2 is 2 times the I4. It means I4 is less than I2. Okay, again one more condition is there, I4 is greater than I3. It means I3 is very small. The current passing through here is very small. If this current passing is very small, then this resistance is bigger. So always remember, R3 resistor is more than other. Okay, going to the next question. Okay, you can see the 2 mark questions now. Observe the figures of a bar magnet given below. Okay, now this is a figure of a bar magnet which is given below. Between the points A and B, this is south pole, this is north pole. Okay, the points are shown here, A and B. In which of the points is the magnitude of the magnetic field lesser? Among this A and B, where the magnetic field is less? And they are asking us mention the reason for that. Okay, so we know that these are the poles of the magnet, south and north pole. Okay, so the magnetic field near the poles are greater. Okay, whereas in the center it will be less. So magnetic field is less at the point B. Okay, let us write, magnetic field is lesser at point B because magnetic field is more near the poles and less at the center. Okay, so that is the answer. Next, 7th one, state Joule's law of heating. Write the mathematical form of this law. Or the question is given, state Ohm's law and define 1 ohm. So these are the most important laws which I have already taught you in my last video. Okay, so if you have not watched that video, the link is provided into the description box. So here the Joule's law of heating is, heat produced in a resistor is directly proportional to square of the current, resistance of the conductor and time for which the current flows. Okay, this is the law, and mathematical form is H is equals to I square RT. Similar way, Ohm's law was also the important law which I have already taught you in my last video. Okay, so the Ohm's law, the statement of Ohm's law is given, and they have told us one more question here, defined 1 ohm. Okay, so what is 1 ohm is, if the potential difference across the ends of the conductor, okay, similarly if the potential difference across the ends of the metallic conductor is 1 volt and current passing through it is 1 ampere, then the resistance of the conductor is 1 ohm. So this is the definition for 1 ohm. You can attempt any one of the question from it. Okay, okay, moving to the next question. These are the 3 mark question. Draw a schematic diagram of a electric circuit comprising of the resistors R1, R2 and R3 connected in series. When 3 resistors are given and they have said you to connect it into the series, you should know you have to draw the diagram of resistors in series. Okay, this is also the important diagram which I have already told you in my into my important diagrams video. Okay, so if just in case if you have not watched that video, the link is provided into the description box. Okay, a battery, a switch and devices. A battery, this is the battery. Okay, then switches. Okay, and the devices in the sense ammeter and voltmeter. Okay, you used to see the devices they have told, they didn't mention what is voltmeter and ammeter, and the devices used to measure potential difference. Which is the device used to measure potential difference? It is voltage of the total resistance, and electric current, and also the electric current, which is the device used to mention electric current, is ammeter. Okay, so voltmeter and ammeter, together with voltmeter and ammeter we need to draw. Okay, next question. Okay, again the same. rule, state right hand thumb rule. This was also the important question which I've already provided into my last video. Okay, so just in case if you have not watched, link is also provided into the description box. Next, write 4 characteristics of magnetic field lines. So we should know the characteristics of magnetic field lines. Okay, so first of all, they are closed curves. Okay, so I hope you have seen the magnetic field line. They are closed curves. Okay, you can see the curved lines over there. They are closed curves. They never intersect each other. Okay, they never intersect each other. They arise from north pole and end to a south pole. The density of field lines is more at the pole. So that is what density of field line is more at the pole. That is what asked in this question. Okay, just a figure diagram this is. Okay, so that is what I said you, the magnetic field lines are more at the poles, density is more. Okay, next, or question, they have given state Fleming's left hand rule. Write the characteristics of magnetic field lines formed around a current carrying circular loop. So Fleming left hand rule already provided into the video, so check the description box for this video. Then characteristics of magnetic field lines in a circular loop. If it is a circular loop as shown in the figure, okay, then the concentric circles, the circles which you can see there, they represent the magnetic field around that particular loop. Concentric circle, you can see the circles around the loop in this manner. Okay, so those concentric circles are magnetic field around that particular loop, and at the center of the loop it appears as a straight line. You can see the straight line near the center. Okay, so that is the characteristics of the magnetic field line. Okay, next question, 10th one. Find the amount of charge flowing in a circuit of 1 ampere of current and flows for 5 minutes in the circuit. Okay, find the amount of charge. Okay, so let us solve the question here. Find the amount of charge. It means Q we have to find out. They have given as 1 ampere. 1 ampere is I is equals to 1 ampere and 5 minutes. T is equals to 5 minutes. Okay, so 5 minutes is equals to 5 into 60, that is 300 seconds. Okay, we have to convert this minute into seconds by multiplying it by 60 seconds. Okay, so now we are having formula Q is equals to IT. Substitute I is 1 into T is 300. So 1 into 300 is 300. C, what is C? C is the SI unit of charge, that is coulomb. Okay, this is the first one. Okay, second one, B, one more question is given. If 2 joules of work is done, okay, B1, W is 2 joules. Okay, so they are asking 1 coulomb of charge. 1 coulomb of charge is Q is equals to 1 coulomb. Okay, from one point to another, then what is the potential difference between the 2 points? Potential difference is V is equals to question mark. We have to find out V value. So we know that V is equals to W by Q. Just substitute the value. W is 2 by 1. It is equals to 2 by 1 is nothing. 2. V is volt. Okay, so this is the solution. 10th one, or question is asked here again. Same questions in different manner. Okay, find the work done if 9 coulomb of charge. Okay, just see first one. Charge Q is equals to 9 coulomb moves between the 2 points having a potential difference of 9 volt. V is equals to 9 volt. Okay, now what they are asking, find the work done. W is equals to question mark. With the same formula they are asking. Okay, but the numericals are different. Okay, just see. Now we are having W is equals to, if we bring this Q to this side, it will become V into Q. Just substitute 9 into 9. 9 nines are 81. Work done is always measured in joules. So work done is equals to 81 joules. Similarly, B1. What is an electric current? Okay, what is an electric current? It means I is equals to question mark. If 3 coulomb of charge, Q is equals to 3 coulomb, flows through a point in 3 second. Okay, sorry, this must be 3 seconds, S not C here. Okay, so T is equals to 3 seconds in an electric circuit. Again the same. Okay, Q, I and T. So we are having the formula Q is equals to I, T we are having, I into T. Okay, here it will become I is equals to Q by T. Just substitute. I value we want, Q is 3 coulomb divided by 3 seconds. So 3 and 3 got cancelled. It means 3 ones are 3, 3 ones are 3. So I is equals to 1 ampere. So the answer is I is equals to 1 ampere. So next question, Roman number 4, answer the following. This is 4-mark question. So they are asking what is overload. Okay, what are the causes for overloading in a domestic electric circuit? Then what is the function of the earth wire? So what is overload and what are the causes for it will contain 2 marks, whereas this function of earth wire will contain 2 marks question. Okay, so just see overload. Overheating. What is overload? Overheating of the electrical wire when the current in the circuit increases abruptly. Okay, when the current increases suddenly into the circuit, the overheating of the electrical wire is known as overloading. Okay, so what are the causes here? When both the wires, the live wire and neutral wire, when it comes into direct contact of each other, then the overloading occurs. Okay, then second condition why it occurs is when we connect so many appliances in the single socket. Okay, next is if the sudden accidental hike in the voltage supply, if there is suddenly hike in the voltage supply, then also the overloading occurs. Okay, next, what is the function of the earth wire? So function of earth wire, it protects us from the electrical shocks. Okay, it protects us from electrical shock if any leakage of the current is present in the electrical appliances. Okay, that is the function of this earth wire. Next, 5-mark question. What is electric power? What is its SI unit of electric power? Write the 3 formulae used to calculate electric power. So first question here is what is electric power? So let us know what is electric power. The rate at which electric energy is dissipated or consumed. Okay, the energy lost. The rate at which the energy is lost or consumed, used in an electric circuit is called as electric power. SI unit of electric power is watt, and the formula, we know that formula P is equals to V into I, voltage into current. Okay, if for this same formula only, V is equals to, what is the value of V according to Ohm's law? V is equals to IR. So again, if I substituted V is equals to IR and this I, it will become I square and R. That is the second formula. Okay, again for this I square R, if I calculate the value of I in according to Ohm's law, I is equals to V by R. Okay, that is square, and into R is present. This 1 R from here and 1 R from here is cancelled. This is squared, correct? It means one more R is remaining. It will become V square and that R is as it is. So this is the third formula. Okay, next, B1 question. What is the function of fuse? What is the difference between the wire used in filament of the bulb and the wire used in fuse with respect to their melting point? So they are asking what is the function of fuse. So what it does is it protects the circuit from overloading and short circuiting. So fuse will melt itself and protect the whatever the electrical appliances from short circuiting and overloading. Okay, so now they are asking the difference between wire used in filament of bulb. You know that the inside the bulb a filament used is called as tungsten. Okay, whereas here in the fuse copper wire is used or any alloy type of wires are used. Okay, so that is the difference. Here tungsten is used. Why tungsten is used? Because whenever the current increases, that particular tungsten must not melt because it is having high melting point. Okay, if it melt it will damage the bulb and there are chances of bursting out that particular bulb. Okay, so tungsten is used here because it has high melting point. Okay, whereas in fuse the copper or any alloy of other metal is used just because the copper is having very low melting point. Okay, at a very low melting point only it will particularly melt, the copper melt and the fuse break, so that to keep the electrical appliances safe. Okay, this is what the particularly part A, physics part. Okay, so in my next video we will deal with the chemistry part. So till then, stay tuned and stay connected. Don't forget to like, share and subscribe. Thank you.